Can you believe it? You're almost done. Again, next week I'll post some optional lectures for extra credit. I only expect the best, most dedicated students of mathematics to complete these, which would be all of you. Before I forget, I want to say that there are three kinds of trigonometric functions that we could be talking about right now: sine, cosine, and tangent. I didn't talk about tangent because it's not on your test, okay? So on your assignment, the 12.10 homework, please feel free to skip all the tangent problems. I'm not going to teach you how to do them. It's basically the same idea, right? You just plug in the values, but the cyclical nature of tangent is very different, because when you're dividing things sine by cosine, as cosine approaches 0, your tangent value becomes asymptotic. And so if you see here, this is a tangent graph right here. You can see there's definitely a pattern, right? But it's very different from sine and cosine. So right here, this week, my goal for our final week of doing mandatory content, my goal is just to make sure that you're good with sine and cosine, okay? And this is going to be a short lecture, okay? Maybe like 10 minutes, hopefully, right? How long have I been so far? I'm at 2 minutes? Okay, maybe like 30 minutes instead. Just kidding. It's just about transformations, specifically translations, because with amplitude and talking about period, we essentially already talked about vertical compression and vertical stretches, right? And horizontal compression, horizontal stretches. Those are kind of the same thing. So all we really talk about is translation. And this is exactly the same as everything else we've talked about in this class in terms of translation. Look at this formula: y equals a times sine of b times the quantity theta minus h plus k. It rolls right off the tongue, doesn't it? Well, what have we talked about already? We've talked about the y equals, and we've talked about what sine looks like. We've talked about theta. We talked about theta just being a substitution for x, right? And we talked about b changing the period of the sinusoidal function, and we talked about a changing the amplitude. So what's new here? We got a minus h now and a plus k, okay? If you were a betting person, and I hope you aren't, because I know I'm not. I only go with certainty. From our past lectures, throughout this entire school year of graphing things over and over and over again and doing transformations, you might think that this k moves the graph up and down, and this h moves things left and right. And if you thought that, you would be correct. That plus k shifts up, minus k shifts down. So that's, I showed you a little bit of that, but so here's y equals cosine of theta. I won't do it with sine because it's the same thing. If I do this plus 2, look, the graph moves up 2. Plus 3, plus 4, plus 5. Very simple. Minus 1, minus 2, minus 3, minus 4. So it's identical. The k is identical in concept to everything else you've learned. And the h is identical in concept too. What does h do? Well, if h is positive, right, things move left. Remember, it's the opposite. Positive is to the right. So if we have a positive, it actually moves it left. And if h is negative, it shifts things to the right. Exactly the same as quadratics and cubics and everything else we've done in this class. Plus h shifts left, minus h shifts right. So if I do cosine, and ideally I'd, let's just do like minus, so let's make it simple, minus 1. Okay, it's kind of hard to see. 2, 3, oh, that's not too bad. 4, 5, 6, 7, 8, 9. It's kind of like a cute little march. I kind of feel like I'm a Pixar animator right now. The ants go marching one by one, hurrah, Hooray. Okay. And so every time my minus gets bigger, you notice the graph is going to the right more. And I just pointed at my screen like you can see like an idiot. +1 goes to the left then. So watch this this point right here. Okay. It won't stay selected. Okay. +1, 2, 3, 4, 5, 6, 7, 8. So you notice it kept going to the left more and more. Okay. That's all there is to it. That's literally it. That's our transformations. Okay. I don't know if there's anything else I have to talk about. I should talk about the midline a little bit. Okay. And just keep in mind that the midline is that middle point. Okay, where it's going through for 0 each time. If someone asks for the equation of the midline, it's just asking what is this horizontal line right here. So if I have a graph like right here, my midline is y = 0. Of course it has to be a color that blends in so well. Y = 0. Good, red, better. So there's my midline. So if I do this as +4, my midline's going to be right here, right in the midline in the middle. It's obvious. Moves in the middle through this. 4. There you go. Goes right through the center, just like you would expect. So I don't think that's difficult. And the rest of this is just applying everything we just talked about, right? We talked about amplitude, 1/2. Where does that come from? Right here, the A value. What's my period going to be? Well, I've got a 3 in front of theta. My base period is 2 pi, and I divide by this. So it's just 2 pi divided by 3, okay? What's the shift? I got a -5 here, so it's going down by 5. Remember, the basic rule is it's inside the parentheses, it's left and right. If it's outside the parentheses, it's up and down. That's all there is to it. Nothing more, nothing less. Okay? Ooh, where was I? Okay. And, where's the midline? The midline is always going to be wherever your vertical shift is, because where is it naturally? And I don't know what naturally means in math, because it's not like you find sinusoidals laying around in the forest. Naturally it's at y = 0, right here, like I showed you. So if I move this up 4, where's my new midline? It's at y = 4. So in other words, the equation of the midline is the same as the k value. So you can see here, this is -5, therefore my midline is y = -5. And it's for sine and cosine. So it's like a -1 right here for my k value. What's the midline? Y = -1. So it's exactly as you think would be the case. Let's talk phase shift. Is just another way of saying the translation left and right, by the way. Okay, so horizontal shift, instead of saying horizontal shifts, you might hear phase shift. Okay, and the idea is just that, like, how are you moving the phases of the cycle, by what quantity? Because a horizontal shift on most graphs, it's like obvious. Like think about, for example, if we what if I take this y = cosine of pi? What if I shift it by 2 pi? Okay, pay attention. I've got a point here and a point here at 0 and 2 pi at y = 1. What if I add +2 pi? It looks identical, right? I still have points at y = 0 and x = 0 and x = 2 pi for y = 1. Why? Because 2 pi is a full circle. So did I move my graph? If you think about it from a horizontal shift perspective, it doesn't look like it changed. But from a phase shift perspective and thinking about how the cycle has changed, we've moved the nature of the cycle over by 2 pi. Even if it doesn't affect the values, right? These values is still the same thing going all the way out infinitely in both directions on the x-axis. So the different terminology helps us convey how this is slightly different from a typical transformation, okay? So, if I have theta plus 2 pi, what's my phase shift? It's 2 pi. And it's going to the left, right? Because this is positive. Positive means you go to the left. And that's it. I don't think there's anything else to talk about. Obviously, this is tangent, so, the things are different. Like you said, this amplitude's undefined. Don't let that throw you off. If you're looking at it like, wait, why is it undefined? It's because it's tangent, okay? Don't worry about tangent. We're not talking about tangent in this class. We only care about the lovely sine and the lovely cosine. We don't care about this wacko tangent that, makes shapes like this. He's not our friend. We don't want him around. That's it. Did I keep it under 10 minutes? Oh, 11 minutes. Dang it. Okay, hey. Did okay. So, take care, guys. I'll see, I hope, all of you, or most of you, next week.